Okay, for the rest of these notes, we're going to be talking about how to sketch these complicated looking rational functions. Here are the directions. 7-step process. You can do this every time. First, factor the denominator and write down all possible vertical asymptotes. We just learned a minute ago that, there we go, vertical asymptotes. We just learned a minute ago that not all of them end up being vertical asymptotes, right? We'll talk about that in a second. Number 2, verify whether there will be a horizontal or a slant asymptote. Okay, that has to do with the degree of the top versus the degree of the bottom. Number 3, factor the numerator to see if any factors cancel, which would leave any holes. So we could cross something off of the vertical asymptote list because something cancels and we have a hole. Number 4, find the y-intercept the same way we always have. Substitute in 0 for x. Number 5, find all x-intercepts by substituting 0 in for y and solve for x. Can I point something out? If you put a 0 right here and you're solving, the denominator is going to get multiplied over times 0 and disappear. So you're really just solving for the numerator equaling 0 because 0 over anything is going to be 0. So if I wanted to find the x-intercepts here, I wouldn't even bother with this denominator. Put a 0 in for x, multiply, that's gone. We just have to solve that equaling 0. Okay? All right, number 6. Find a point by substituting an x value on both sides of every vertical asymptote. That's time consuming, but it helps make sure you sketch the thing correctly. Sketch your graph. Don't forget to add a hole if it exists. It's real easy to forget at the end that something canceled, you're supposed to leave a hole. Okay, here we go. Sketch the graph of each rational function. This factors to x plus 1 and x minus 1, but none of that is going to cancel with this x. So no canceling, no holes. So I'm going to go to where it says holes. I'm going to say there are none. Okay, the vertical asymptote is just x equals 0. So the y-axis is actually going to be a vertical asymptote for us. Okay, horizontal or slant asymptote. Well, the degree is higher in the numerator than it is in the denominator. So horizontal asymptote, there is none. This one is an actual slant asymptote. So I got to do division. X dividing into x squared minus 1. To get that x to be x squared, I go times x. Multiply that, I get x squared. When I subtract, I get negative 1, and that does not divide in. That's a remainder. I don't care about the remainder. I only care about the quotient. So y equals x is my slant asymptote. Real easy to draw. Goes from corner to corner. Y equals x, slant asymptote. Okay, now I should get some points. I found my denominator, my vertical asymptotes. I found out that it's a slant asymptote. I factored, nothing canceled. I should get the y-intercept and the x-intercept. Y-intercept's real easy. Put a 0 in for x. Okay, f of 0 equals 0 squared minus 1 over 0. Negative 1 over 0, that doesn't exist. Well, I should have known that there's no y-intercept. It's a vertical asymptote. That didn't work. So there, I should have a spot here for x and y-intercepts. I'll just go x-intercept and y-intercept. I'm going to say there is none. Okay, for the x-intercepts, I'll go over here and I'll write x-intercept. I'm going to put 0 in for y and I'm going to solve for x. Well, the first thing I would do is multiply by the denominator, and it just disappears. Then I'm going to add 1, and I get 1 is equal to x squared, and so x equals plus or minus 1. So at x equals 1, and x equals negative 1, at 1 and negative 1, I have actual x-intercepts. Now the other thing I would do is I would put a point on both sides of the vertical asymptote, but look, I already found one. So this point tells me everything is above this asymptote. So I stay above the slant asymptote, I hit this point, and I go up towards the left side of that vertical asymptote. On the right, I have a point that's below the slant asymptote, and so this one is going to stay on the right side of this vertical asymptote, hit this point, and then it goes up. Okay. Factor the denominator. That was already factored. Vertical asymptotes, x equals 0. See if it's horizontal or slant. Because there was a bigger degree here, it's a slant asymptote. So no horizontal asymptote. I did long division, got y equals x. I found my x-intercepts, and they served as points on both sides of the vertical asymptote, so I didn't even have to do number 6 because I did number 4 or number 5. And then sketch my graph. Here's your job. Try and find all your important stuff for number 2 and sketch that graph. See what happens.